All right, so taking a look at questions 1 through 4, which is the first 3 pages of your test. If you look at the top right-hand corner of your exam, it says exam 4-2 or exam 4 number 1. Okay, so if you've got exam 4 number 1, it's a different version than exam 4 number 2. Occasionally a problem will match, but very rarely. So if you'll just let me know which version of your exam you have. I do have my exam versions here with me today, and I can respond to the one you have. Okay, so anybody have a question on questions 1 through 4? 1, 2, 3.
What's like the thing for it to be a function?
Good. All right, so in order for a graph to be a function, it has to pass the vertical line test. So we draw vertical lines, and if it crosses twice, it's not a function. As long as it never crosses twice, it is a function. And later on, we had something called one-to-one. One-to-one functions are the horizontal line test. Same rule. If it crosses once, we're good to go. If it ever crosses twice, it's not a one-to-one function. So that's what you're looking for on problem number 1, is dropping in vertical lines. Okay, do you have a question, Sarah?
We do number 2.
Okay, which exam version do you have?
1.
Exam 1, version 1, problem number 2. Okay, so I will write up what your exam version says on here. And so if you don't have this exam version, I would encourage you to still write this down, because, right, this is a good question. It's going to match your exam 2 version as well. It's just going to have a different function in it. So our function on exam 1, or on Sarah's exam that she mentioned, right? I think she said exam 1. Looks like this. Sarah, is this true? Is that your question? Fabulous. Okay, and the question asked her to find, and half of you to find, h of x minus 2. Okay, so anytime you put the value inside the parentheses, right beside h like that, it means that's a replacement for what x is in the function as it was originally described. So in essence, this piece has now become this. So everywhere I have an x, now I need to replace it with x minus 2. Like that. Okay, so that's the real math of the problem, right? The replacement effect. Everything else is algebra simplification, right? We've replaced it, and now we're going to simplify. The directions say to, actually, is just so you know, it says simplify as much as possible. So in the denominator, what you want to remember is that this piece multiplies out to x minus 2 times x minus 2. So I have a 6, and then if I have x minus 2 times x minus 2, it's x squared minus the inside terms are negative 2x and the outside terms are negative 2x, so that's negative 4x. And then the last terms multiplied are positive 4. And all of this still has a plus 7 at the end. All right, so moving and cleaning up by multiplying through, I have now 6x squared minus 24x plus 24 plus 7. And the only other thing to do is to add the 24 and the 7 to give me what? $31? And we'd be finished then. Is that good, Sarah? Okay. What else? Questions 1 through 4. If you want to see an additional problem, I mean, like you can just say, like, let's say you had the other version of the exam, so your exam or your exam question on number 2 is different. You still want to see it? You can still say that, and I will do it too. Okay. Okay, that's a good question. So, which test do you have?
1.
Okay. All right. So, deciding if something is a function from an equation standpoint, what you're looking for is you're looking for any way that y could end up having 2 values. The 2 ways that we've had that happen are square roots and absolute values, okay, or squares and absolute values, depending on the perspective. So if you see y being squared, it would mean you'd have to take a square root, and when you take a square root, you put in a plus or minus. The plus or minus is the problem. If you see absolute values where the y is inside of absolute values, in order to eliminate them, you end up having pluses or minuses. So it's really about the duplicating the numbers by putting pluses or minus in. So in particular, if you see y squared equals the number, or anything really, or the absolute value of y equaling something, that was an x, not a y. So if these things are happening, it's not a function. So on your test, the only place that happened is in the fourth example, x equals 5y squared minus 1. Y is squared, so it's not a function. But in all of the other cases, y is not squared and there's no absolute values, so they are.
So I only look at y, like it can't be like z.
Right, it's all about y, because the y doing that is what creates that vertical line test problem. Otherwise, it does create a horizontal line test problem, but we're not talking about one-to-one functions, we're just talking about functions, period. Anything else in questions 1 through 4? Okay, and you had exam 1, right, Sarah? Okay, so Sarah's test has this picture on it. Is that right? No, yours is the other one. Roughly this. And it asks you to find g of 2. So this notation right here is telling you that this is an x value. Tells you x is 2. And if you look on your graph, that location on your graph is where I've put my red dot. X is 2 there. So like if you were to write an ordered pair, this would be the ordered pair 2, 1 on your test. So this notation is saying if x is 2, what's y? And the answer is 1. So that notation is simply telling you, write yourself a note if you need to remember, this notation means x is 2. What is y? Okay? Same thing for the other test. So if you have the other test, your test looked like this, and it asked for f of 0. So again, it's telling you here that x is 0, and over here on the graph, this is the value where x is 0. And on that one, the y value is 2. My scale looks really funny compared to the other graph, but that's okay. And so your answer is 2, because your answer is, what's the y value?
That first graph should be -1.
Oh, -1. I'm sorry. Yes, thank you. My bad. Is that what you have, Sarah? I'm sorry. Sorry, I was just moving too quickly. Yeah, it's -1. Thanks, Trey. Okay, so when we talked about the final counting for more than one grade, we talked about note cards. Did we talk about note cards for this class? Not yet? Okay. Not too many classes is my problem. Okay, so on your final exam, you get a note card. Yahweh. 3 by 5, that's the little one. You bring me in a 5 by 7, we're going to have problems. The little one, all right? You can write on the front, you can write on the back. You get 1 card. Don't go trying to like split the card in half and like make it like double-sided so you've got 4 of them. That's not appropriate. 1 card front and back. Handwritten by you. So like Devin, you can't pay Preston to write you a card. It's not appropriate, okay? Got to write your own card. So handwritten by you, and you'll leave it with me when you leave the test. Okay? Is that good? Awesome. Okay. How about questions 5 through 8? Anything in 5 through 8? Number 5, which test do you have? Exam 2, number 5. Okay, so this graph, I'll sketch it. It's not going to be great, but we'll go. It looks something like this. Actually, you know what? Let's do this. Have you guys seen me do this? Isn't that amazing? It's got a grid. And let me make my grid a little bigger, actually. Okay. On Jack's grid, it starts at -3 here, goes down to 4. -5. Did you just say exam 2? Okay, well, I'm going to leave it on here. We'll talk about it second then. Sorry. They do slightly different things, so it's probably good that we talk about both of the graphs just to give you some perspective. Sorry about that, though. All right. Okay, this is Jack's then. Sorry about that. Okay, so if you count, my grid marks should be right on your test. And I think they asked the domain and range, right? Domain and range. So domain range, which one's X, which one's Y? X is domain, Y is range. So we're going to have our domain, we're going to have our range. Domain is X values. We start the X values by starting at the far left-hand side of the graph and we walk along the Y axis, or along the X axis, looking up and down and finding where is our first Y value, where is our first point on the graph, and where does it end. So where's the first point on this graph? Where does it start? It's at -5, X value, right? So -5. And it's an open circle, so I'm putting a parenthesis. And as I'm walking along, when do I stop seeing Y value, or stop seeing point values? All the way over 3, because there's a disconnect right here where one of them's open, this one's open, but that one's filled in closed, so it continues, it just jumps down, and then I stop at 3. Yeah, good. And at 3, do I have a parenthesis or a bracket? A bracket, because I have a closed circle. Okay, so range is the same thing, it's just that we start on the bottom of the y-axis and we climb. So if I start on the bottom of the y-axis, where do I first start seeing values? At -3. And do I have a parenthesis or a bracket there? A bracket, because it's a closed-in circle. When do I stop seeing values? At least for a time. At 1. So at this point right here, I pause on what I'm seeing. I can still keep climbing, I'm just not seeing anything that I have on my red part of my graph. So, and there's a bracket there because it's a closed circle. We usually see a union. You don't want to put a U, I don't care, put a parenthesis or a comma, put a comma or just leave it blank, it doesn't matter, but it's a break. And then if I keep climbing, where do I start seeing the Y values happening again? At 4. And do I have a parenthesis or a bracket at 4? Parenthesis, and if I keep climbing up, where again do I stop seeing Y values or graph that's red? At 5. And again, I have a parenthesis there because it's another open circle. So this is what it would look like. Let's try that again with the other test because it does something slightly different. The interesting thing on this one is because when you look at Y values on this one, they overlap. As you're climbing up along the range, you're looking your left to your right, and there are points when you see values on both sides, which feels a little bit different than the other equation. The other graph didn't do that. So if I'm doing the domain for this one, the X values, and I start on the far left, where is the first X value that I see? -3. And do I have a parenthesis or a bracket there? A bracket because it's a closed-in circle. And as I'm again walking along the x-axis, where do I stop seeing values? At -2. And I have another bracket. There's a break. I keep walking for a long time. I don't see anything. All right, it's like when you're driving along the highway and you get to those patches where there's no gas station forever, and then all of a sudden you see like 15 gas stations in 2 minutes, right? You know what I'm talking about. You start to notice these things when you have children that need to go to the bathroom all the time. Yeah, just saying. All right, where do you start seeing values again as you keep walking? Yeah, at 4, x values, so at x equals 4. And at 4, do I have a parenthesis or a bracket? A parenthesis. And I keep walking, and where do I stop seeing values? 5. And another parenthesis for the open circle. My range is weird, that's okay. As I'm starting along the y-axis from the bottom, climbing up, where do I first see y values? Yeah, negative what? 5, right. I thought I heard 4, so I wanted to check. -5. And as I keep climbing up, there's portions of the graph where I see values to the left and to the right. It doesn't really matter. I just need to see them somewhere. So where do I stop seeing y values? That was a parenthesis. At 2? Yep. And at 2, it's another open circle. So the range really is not affected by the values over here on this little piece, right? Not really. The other piece overtakes it because it's got all the values that are connected anyway, so it's enough for it to be over there. All right, what's next?
Number 6. This is a question about the local maximum value of each.
Okay, which test do you have?
1.
Test 1. Okay.
And that's supposed to be the y value.
Yeah, maximum values or minimum values, where it says what are the local max or the local min, they're asking for the y value at those peaks or valleys. If it asks you where do they occur, which is the first question, says what value, where at what values does it have one? That's the x values. So like on your test, the first question, at all values at which h has a local maximum, that's asking for the x values. All local maximum values is the y values.
The y values
Yeah, of the maximum points. So if you have a point like this on your test, the first question says what's the x value there at that point, and the second question says what is the y value there at that point. And that's how it is in the other test too, same order. X value at that point, y value at that point. Okay, anything else in 5 through 8?
So on 6, it
Uh-huh.
says local minimum is x values, and if it just says, well, I guess the might say all.
Yeah, look
But
carefully.
The top one, it means x values, and the bottom one, it means y values.
Yeah, because the language says this, all values at which, one of them's called F, one of them's called H. I'll just use F. F has,
Both of them are said that.
I know, but you have one test. There's 2 tests in the room, so I'm saying the other test says H. Has a local minimum. The other one says local maximum. The second question, this is one question, and the second question says all local minimum values. Okay? This is the y value. But all values at which is an x value. Okay? It would be like asking, if you looked back over your high school transcript, all semesters in which you had at least a 3-point GPA. Okay, well that was fall of 2007, and that was fall of 2009, and that was spring of 2004, whatever. Okay, those are the when did it happen. The second question is, what was the GPA, right? What were those values? When did they not when did they happen instead, but what were they? Okay, so that's the second question. What are the values that are happening at those points in time? Okay, anything else 5 through 8? Seven, which test do you have? Test 1. Okay, there's a picture on this one. We'll see if I can get a sketch. Okay, your question actually says, answer the following questions. So it starts over here at -5, 1, up to -2, 3, down to 0, 1, here, 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 and here. Okay, so this is the graph that's on test 1 for problem number 7. And it asks a series of questions. It asks, on part A, is f of 5 positive? Okay, so what does it mean when it says f of 5? Yep, when x equals 5. So when x equals 5 would be here. It's an x value of 5. Is that a positive y value? No. So it's not positive. So it's asking, what is the y value doing at this particular x value? Is it positive? The answer is no. It says on part B, for which values of x is f of x positive? So it's asking where. Where is f of x positive? So graphically, what does f of x mean? Y. Okay, so f of x means y values. And on a graph, visually speaking, where are y values positive? Right, the x-axis and above, actually, right? Not just 0, but where we've got an x-axis and above. So anything up here are positive y values. So this is asking where is y greater than or equal 0. Now, clearly our whole graph is not above the x-axis, right? But portions of it are. In particular, this portion of the graph and this portion of the graph. So looking at those portions of the graph, we have to report back to the questions to answer it where those x values are occurring. So again, kind of like we did with domain, if we start from the left and we work towards the right, what x values are we talking about? Well, on the far left, that's an x value of -5. So if I start at -5, I'm already above the x-axis. And if I go all the way until I get to the origin, I still have positive y values. But at the origin, I actually equal 0. I'm not positive, I'm not greater than 0, so it's a parenthesis. And then I dip down underneath the axis, and then I keep going, and then back when I get to number 2, the x value of 2, again, I'm above the x-axis until I get over to 4, where I hit 0 again, and then I dip down below. So these are the values where f of x is greater than 0. And then C says the values where f of x equals 0. Okay, so f of x equals 0 are the x-intercepts right here, here, and here. And it just asks for the x values at those locations. So what would those x values be? 0, 2, and 4.
On B, will those be parentheses, or do we have to put brackets on it?
They're parentheses because it asks where it was greater than 0. And at those endpoints, it's equal to 0. So it exists, it's part of our graph, it just doesn't satisfy the condition of being greater than or 0. If it said greater than or equal to, then you'd include it.
Okay, yeah.
Yeah.
The other test has greater.
Yes, it does. The other test has greater than or equal to, so those got included with bracket notation if they actually hit the x-axis. Good notion, good observation. Anything else in 7 through 8, or 5 through 8? Okay, how about 9 to 12? 9, 10, 11, 12.
I have a question about that.
Okay. 9's another graph. I should just leave my graph notation up. Which test is it? Test 1. Okay. Okay, so number 9 asks us to graph the function f of x equals the square root of x plus 3. We know what the square root of x function looks like. We talked about it. It has a basic image. I'll just draw the basic image in real quick to start with, just as a reference point. It hits the origin. It has this 0.11, and then we connect it like that. That's the standard graph of y equals square root of x. How is our function given here different than that graph? Right, the plus 3 at the end means I need to move up 3. So in particular, there are sort of 3 things that I was looking for. I was looking for whether or not you moved each of those particular points. So like the origin, where it is, needs to be at 3 here, and that should be plotted, like actually drawn in like a dot, right? And this ordered pair, which would have been at 1, 1, also replotted, like that, and then connected. Those are the 3 things I was looking for. 3 points on that problem for those 3 things. So this is the graph's f of x that I'm given. You didn't necessarily have to draw this one at all. I just put it in there so that we could talk about it, that's all. Anything else, 9 to 12? Transformations, up, down, left, right, stretch it out of shape, reflect, all that good stuff is what we're talking about here. Okay then, 13 to 16. Couple more graphs and then back to some other things.
We do 13.
Yep,
Test 2.
13 on test 2. Okay, so 13, there's 2 parts. Do you care which part, or do you want both parts, or both? Okay. So just be aware on 13, if you have version 1, yours switches A and B's requests. Okay, they switched the questions they're asking. So please don't look at this and think, oh, look, that's why mine, no. Part A on this test is actually part B on the other test in terms of like the question that's being asked. So they tell you on part A that they are giving you y equals f of x, and they want you to draw y equals negative f of x on this test. Is that what yours says, Preston? With the negative outside, yeah? Okay, good deal. And so the graph that's given starts out looking like -4 to this. Okay, this was what his graph looked like on part A. Go for a little bit. Okay, so what does the negative when it's outside in front of a function do? It reflects it, but how does it reflect it? Up and down or left and right? It reflects it over the x. It reflects it up or down, okay? So this needs to reflect, in this case, down underneath the x-axis. So what I was looking for is for you to take each of the points that are endpoints or locations where it changes direction. In this case, there's only endpoints, and to reflect them. So like this one is up 1, so now it needs to go down 1. So the new point should be this one. And the end point over here on this other one is up 5. So we need to go down 5 and plot that point, and then to connect the 2 endpoints together. That would be the reflection we're looking for. Okay? Plotting the points that you can plot that are, you know, sort of directional where they've changed, and then you have the same image between. If you do part B for that same test, it's a funner one. Funner's a good word, isn't it? We should use that word a lot. Funner. Okay, it actually tells you to do the opposite. It says y equals g of x is given, and it wants us to graph y equals g of negative x. Let me draw what's given, because it's a bigger graph. Oh wait, sorry, that was, I've got to figure out what was starting with. It starts right here. Okay, so the original graph given looked like this blue one with my red dots. Is that right, Preston? Did I get your graph drawn right? Does that look right?
Yeah.
Okay, cool. So if the negative is inside with x, it's also a reflection, but instead of it being a reflection up and down, it's a reflection over the y-axis. I go left and right. So everything on this side now that's on the right-hand side has to flip over to the left-hand side and be a mirror image. So the nice thing is, in particular, this first dot doesn't change, right? It's on the origin. You can't flip the origin. The origin doesn't flip anywhere when you reflect it. It stays constant. The point that you have right here has to go 3 to the left instead. And then the last ordered pair that is 7 to the right will be 7 to the left and above. So it goes right here. And then if we connect those dots, we end up with this image. So end up with a big old giant W when I'm done. So if you're looking at your test and you have the other test, yours flipped those around. So your part B flipped it like this. Everything that was up flipped down, or actually yours was down. It was below the x-axis and it flipped up. And on part A, it flipped it around the y-axis, but it actually surrounded the y-axis to start with. Let me actually do that part because it feels quite different when it surrounds the y-axis to flip it. So on this one, it looked like -4, -5. Okay, I think it looks like this, if I got my pieces in the right spot. This is how it started. And so everything that's left goes right and right goes left, but that feels different because, you know, I'm still going to be crossing the y-axis. So this point right here will come over here to here, and this point will come over here to here. They both happen to be 4 distances away from the y-axis, is why that's happening. And if I connect my two new points, I would end up with it looking like a giant X when I'm done. So on one test you got a W, and on the other test you got an X. Anything else in 13 through 16? Just one. Okay, on test 1, number 16, said Q of x equals -4x minus 4. R of x equals -2x minus 2. And they don't label them A and B, but I will. Part A wants us to find R of Q of 5. And part B wants us to find Q of R of 5. All right, so when we talk about order of operations, we talk about how we start from the inside and we work our way out, right? You start inside parentheses and then you sort of build yourself working outside. The same thing's true here. We're starting with the most inside thing, which means that the first thing I need to do is to calculate this. Find what is Q of 5. Okay, so Q of 5 means I take the equation for Q, which I was given, and what do I do with 5? I substitute it in for x. So my Q of x equation was my top equation, so -4 times my new value 5, which is x, minus 4. So what is -4 times 5 minus 4? What is it? -24 is right, yep. And then as I move my way out, the next step on the outside, the R with the circle part, is the same notation. Another way of writing this would be R parenthesis Q parenthesis 5, alternate notation. So what I have now found is that this piece inside, all this, is being replaced with a -24. Okay, so I can now take the R equation and I can put in a -24 and do the same thing. So my second equation was my R equation. It's -2 times the new x value, -24, and then minus 2. So what's -2 times -24? Positive 48 minus 2 would be 46. Now, the order matters. The fact that I did Q first and then I did R is going to make the next answer when I do it the other order not the same. Could it possibly be the same? It could. But it's very rare in very special circumstances when it does happen that way. So if I go in the other order and I start with R of 5, I would have -2 times 5 minus 2. So it's -2 times 5. -10 minus 2 would be -12. And then I would take the Q equation and I would plug in the -12 that I just found for x. So that's -4 times -12 minus the 4. So what is -4 times -12? What is it? 48, and what's 48 minus 4? 44. They're actually pretty close, but they're not the same. They do not even have to be close, actually. Yes, sir.
I just now noticed I've got that light on Teams.
Okay, let's chat afterwards. Grading things happen. Sure. Okay, so they had P and Q on the other test. Is that right, McKaylee? Okay, so P of X is negative X plus 2. Q of X is negative 2X squared minus 2. Part A was to find P of Q of negative 2. Okay, so we start in the inside here with Q of negative 2. So Q of negative 2 means to take the Q equation, which is negative 2, times X, which is now negative 2, squared minus 2. All right, so we have lots of negatives here. What is negative 2 squared, working inside out? Positive 4. And then positive 4 times the negative 2 at the beginning would be negative 8. And negative 8 minus the 2 at the end would be negative 10. Good job. All right, cool. And then we're going to take the P equation and we're going to plug in that negative 10. So in P, I have negative times my new negative 10 plus my 2. What is negative of negative 10? Positive 10. And 10 plus 2 would be 12. On part B, I'm asked to do the opposite order, Q of P of negative 2. So P is where it started. Yeah, P of negative 2. So I have the opposite of negative 2 plus 2. So what's the opposite of negative 2? 2 plus 2 would be 4. And then Q of 4, my new value, would be negative 2 times 4 squared minus 2. So what's 4 squared? 16. 16 times negative 2 would be negative 32, and negative 32 minus 2 would be negative 34. You're welcome to punch them in your calculator to make sure you don't make a simple mistake or something like that. It's fine. You don't need to do it in your head, but yeah, it'd be negative 34. Anything else 13 through 16? Yes, as long as 13 through 16 we're all finished.
Oh, sorry.
It's okay. Do you have one more before we do that?
Yeah, could we do
15. Which test, Evan?
2?
Okay. Okay, so on 15, that's a terrible 5. That's better. You have g of x equals 2x squared minus 3, and f of x equals 9x minus 9. There are 2 questions. Part A says to find g of f over f of 4. And part B says to find values not in the domain. Of g over f. Okay, so g over f of 4 literally means g of 4 over f of 4. So I'm going to take the number 4 and I'm going to plug it in for the g, or for the x in the g equation. So that would be 2 times 4 squared minus 3 over 9 times 4 minus 9. Okay, simplifying. 4 squared is 16 times 2 is 32, and 32 minus 3 is 29. 9 times 4 is 36 minus 9 is 27. And if it reduced, we would reduce it. This one doesn't. 29 is prime, so there's nothing we can do to simplify. We just leave it. Part B, when it talks about values not in the domain, they're talking about putting the g of x function over the f of x function. So g would be 2x squared minus 3 over 9x minus 9. And literally, for it to be a problem with the domain, it means it would make the denominator 0. So whether or not you show any work for it, you probably can look at that and tell me what the x value is that would make that 0. What x value could I not use here? Yeah, 1. X equal 1 would be the one and only, in this case, place where the domain would not, or where the x value could not be used. It would not be in the domain. And that's what this question was asking. We good? Okay, 17. Keely, was that when you?
Yes.
Okay, which test do you have? 2? All right. 17 says that f of x equals 2 over x plus 3, and g of x equals 5 over x minus 1. And part A wants me to write f composed g of x, and then part B wants me to find the domain. Of f composed g. All right. So again, inside function g of x, that's this piece right here, right? And literally what this is saying is to take what g of x equals and to plug it into the x in the outside equation. So the outside equation is our overall outside equation, like this. But in place of where x was, I have the other equation's output, which is 5 over x minus 1. That's what it tells us to do. Plug the g of x equation into the x location in the other f of x location, f of x equation. And then we need to clean that up because that's not cool. Now, it's important to realize when I plugged this in right there already is that we cannot have x equal to 1. Do you guys see that? That would make the little denominator we're dealing with equal to 0. Okay, so that's something we're going to need to know in a little bit here. We can't have x equal to 1. There's going to be other potential places that are problems too, but that's one of them. All right, so when we did this back in intermediate algebra, we talked about the fact that this is called a complex fraction because there's a fraction inside of a fraction. So complex doesn't mean complicated, but it kind of feels complicated, right? It does. So we'd like to eliminate the fraction inside of the fraction, and the way that we would do that is we would take the denominator of the little fraction and we would multiply by it. Now, in the denominator, when I do that, it has to apply both to the fraction and to the 3. And then in the numerator, it applies to the 2. And we'll have to distribute. So in the numerator, when I take the 2 times x plus 1, I have 2x plus 2. In the denominator, on the first piece, the fractional piece, the whole point was it would cancel with the denominator. So the x plus 1 that I'm multiplying by and the x plus 1 that's in the denominator, those cancel. And all I'm left with is a 5.
5x minus.
Oh, are they ones, minuses? I'm sorry. I zoom in and zoom out on my screen a lot, and that's why I lose things. That's what's going on, just so y'all know. Is that, like right now, this is my screen. Do you see it? I can't see anything. You guys see the whole picture, and I only see part of it. Otherwise, my writing's too small. Okay, thank you. We'll get that fixed, you bet. Okay. X minus 1 then, my bad. All right, so the x minus 1 in the denominator of the little fraction cancels with the x minus 1 that I'm multiplying by. So I'm only left with a 5. And then the 3 has to be multiplied by it as well. So I will get 3x, and then 3 times minus 1 would be minus 3. I don't care who you are, but that's way better than it was before. Just is. I mean, even stopping right here is so much better than where we were. We can do one more step to clean up the denominator, though. I have 2x minus 2 in the numerator, and I have 3x plus 2 in the denominator. Is that good? Okay. There is still a value, however, at the end of this problem that x cannot equal. It will be a value that makes my denominator equal to 0. So this one you might not be able to see quite as quickly as the last one that we did. So if I set 3x plus 2 equal to 0, and I solved it, I would have 3x equal to negative 2, and then x equal to negative 2/3. That is an additional value that I now have that x cannot be and make this work. So down here, not only can x not equal 1, but x cannot equal negative 2/3. So these are both locations where it can't happen. And if you think about, like, from a number line perspective, the negative 2/3 comes before the 1, right? So if you're thinking about writing this as an interval, because that's what it asked you for, is interval notation, you would have negative infinity to negative 2/3. You'd have negative 2/3 to 1, and then you'd have 1 to infinity. There's 3 different locations excluding, that's why we're using the parentheses, excluding the values negative 2/3 and 1.
So we got the 1 from the 5 over the x minus 1?
Yes.
Okay, so if we're solving it backwards, like we want to plug f into the g equation?
Yes.
So it would be negative 3.
Yes, exactly.
So we always do that?
Yeah, it's whatever the input is that you have to look at for the domain problem, as well as the final output.
Okay.
Yeah, so there's 2 locations. The first one is the original input here, and the second one is the final output here.
Okay.
So don't just go looking at all the denominators that are in your problem. That's not, you're going to end up with extra stuff that's not true. Anything else 17 through 20? 19 on which test? Number 2. Okay, so 19 has several pieces. It says g of x equals x plus 13 over 7. It says h is a series of ordered pairs, -5, 1, 3, -4, 6, -5, and 7, 8. And then there are basically 3 questions it asks. The first question it asks is, what is g inverse of x? The second question it asks is, what is g inverse of g of 6, -6? And the third question it asks is, what is h inverse of -5? Did I get them all written in there? Who asked for this one? Jack did? Okay, cool. Okay, let me skip A because B and C are the easiest ones to answer. Okay? The reason that they're easy to answer is because, well, C is because I'm given ordered pairs. B is because it always ends up being itself. When you take a function with its inverse, it just reoperates on itself. So you end up just getting the -6 that's the input. So it doesn't matter what g is. This will always happen. Okay? So the fact is that when I have the inverse notation composed with the original notation in either order, I could put the inverse first or second. It would still end up giving me the same input value when I'm done. Okay? So it's like saying, you know, when I leave in the morning and I come to school, and then if I go to school and I go back home, where do I end up? Well, at home where I started, I just inverted my process, right? I did it backwards, and that's what inverses are. On part C, we talked a minute ago about the notation, say, f of 7, meaning 7 is x, find y. Well, when we have inverse notation, it's opposite. So this is saying y is -5, find x. And the reason that I know that is because of this. That little inverse says do it the other way. Flip it, do it opposite. Okay? So looking at the ordered pairs that you're given, the third ordered pair has a y value of -5. So its x value would be 6. And that'd be your answer. Okay, so B and C are definitely hands down easier than part A. Part A is the one where we literally have to do some work. What we do is we switch where x and y are and we resolve for our new y. So this is x equals, and I have y plus 13 over 7. Okay, so y, or f of x, becomes x, or g of x in this case, and x becomes y. And then I have to solve. So what would I do first to solve this? Multiply by 7, you betcha. So now I have 7x equals y plus 13, and then what? Subtract 13. So then I would have y equals 7x minus 13, and I would just invert my notation. So g inverse is my notation, equals 7x minus 13. Okay, it's not super crazy hard work, but it's more work than B and C.
I don't really understand the
Okay, let me actually do it so you can see why it works. Maybe that will help. Okay, so the reality is that whatever this is going to be. That's the reality. But here's why. Let's say I took -6 and I put it into here. Literally, what would I do? Well, I'd take -6 and I'd multiply it by 7, and then I'd subtract 13, right? But then when I took that answer, I would take that answer and I would add 13, and then I would divide by 7. Do you see I undid the same things? So in one case, I multiplied by 7. In the other case, I divided by 7. In one case, I added 13. In the other case, I subtracted 13. And so that's why it puts you back where you started. It's like retracing your steps. You guys have retraced your steps before when you forget something, right? Like, where did I put those things in? So you retrace all your steps. That's what inverses are. It's retracing your steps. Retracing your steps. What else? 17 through 20. 20 on test 1. Okay, so this is another similar example on finding inverses. It tells you f of x is cube root of x minus 9 plus 3, and it wants you to find f inverse of x. Okay, so just like on the last problem, this is just a harder one, I want to switch x's and y's. So this notation means y, right? It means y. So instead of it being y, I now want it to be x. And I want my x to now be y. Okay, is that all good? Okay, our goal now is to solve for y. And when we're solving for y, we have to work from the outside in, right? When we're simplifying, we work from the inside out. But I'm not simplifying. I need to get the inside out of there. So I have to first start with my 3. So I'll subtract my 3 to the other side. And then what would I do next to solve for y? How do I get rid of a cube root? A cube, right. So I'll cube. I do not expect nor want you to multiply that out. We're going to leave it as x cubed minus, or x minus 3 cubed. On the right, again, the whole point in doing so is that the cube root and the cube cancel, leaving me with y minus 9. And then what would I do? Add 9. So now I have y equals x minus 3 cubed plus 9. And then the last thing is to just change the notation. So instead of it saying y, it'll say f inverse of x. Or if you started with g, it would say g inverse of x or whatever. Is that okay, Karen? Okay. 17 through 20. Sure. Okay, same direction, so I won't write them down. I need to switch the x's and y's first, so this will be x. And then I have 3y minus, or plus, excuse me, 8. All right, so on this one, everything is underneath the radical, so I don't add or subtract first. I first have to get rid of the radical. Just like the other radical, I get rid of a cube root by cubing. So now I have x cubed on the left, and the cube root and the cube cancel on the right to leave me with 3y plus 8. What would be next? Right, I would subtract the 8, moving outside in. So now I have x cubed minus 8 equals 3y. And then divide by 3. So now my y equals x cubed minus 8 divided by 3. And my last step would be to rewrite it with the proper notation, which is that inverse notation. F inverse of x equals x cubed minus 8 over 3. Okay, how about 21 to 24? 23 on which test? Okay. We're supposed to find the x-intercepts and the vertex of the parabola y equals negative x squared plus 4x plus 12. Okay, so I'm going to sort of identify that there's two pieces I'm supposed to find. I'm supposed to find x-intercepts, and I'm supposed to find the vertex. Is that okay? So far so good. Okay. X-intercepts are found when y equals 0. So we let 0 in for y, and we're trying to solve. Now, it's quadratic, right? There are 3 ways you can solve a quadratic equation. The simplest, if it works, is factoring. It's the quickest. The second one, which works all the time, is quadratic formula. The third, which takes the most work, is completing the square. Right? But there's 3 ways that they can always be solved. If it factors, we want to factor. And this one will, so let's take a look. I think it will. Yeah, it will. It's really not so very friendly to have a negative at the beginning of the x squared. It's doable, we could work with it, but there's just no need. If I multiply everything by a -1, it'll be easier to work with. So I'm going to do that. I'm going to multiply by a -1. And you might be like, well, Dr. Hans, are we really allowed to do that? And the answer is yes. If you multiply both sides by the same number, you can do that. And we do it all the time. So if we multiply the left by -1, it doesn't change because it's 0. And we multiply the right by -1, all my signs change. All right, so I will start you out. I have x at the beginning of each of my factors. What will my signs be? A negative and a positive. How come, Megan? Yep, the 12 at the end tells me I need a negative and a positive. The 12 also tells me I need 2 numbers that multiply to 12, and they have to add to 4, or subtract to 4. 6 and 2 will do it. And I want the 4 in the middle to be negative, so my 6 will be negative, and my 2 will be positive to give me a negative 4 in the middle, right? If you check the inside and the outside terms, I'll get a -4. Setting each of these equal to 0, x minus 6 equals 0, gives me x is 6. And x plus 2 is 0, gives me x is -2. I said negative and I didn't write it. There we go, -2. So my x-intercepts are 6, 0, and -2, 0. There are 2 of them. Pretty typical for a parabola. Crosses the x-axis twice. Okay, vertex. how do we find vertex? There are other ways, but we have only talked about one way. And the way we talked about was to complete the square. Okay? So I have y equals negative x squared plus 4x plus 12. To complete the square, we would factor out the negative, which leaves me with x squared minus 4x, and we would pull out the 12 at the end. I need to fill in this blank. The way I fill in the blank is that I look at the middle term, negative 4. I need to do negative 4 divided by 2 squared. It's a positive 4. But the reality is that this positive 4 is also multiplied by the negative on the outside, right? So when I put it in, I really put a negative 4 into my equation. Are you with me? So I have to balance that by putting a positive 4 on the end. So I didn't actually change the value. Okay, cool. So then I'm able to factor perfectly what's inside the parentheses. The whole point is that it will factor as x, and then the middle term will be divided by 2, so minus 2 squared. And at the end, I have positive 16. Okay, so that's sort of the hidden part of how do we find this. It doesn't specifically say complete the square, but completing the square is the method by which we find the vertex, and the vertex is here. You change the sign on the term by x, and you leave the sign on the y on the outside the same. So my vertex is 2, 16. All right, 21 to 24. What else? (24) on which test? 2. It says answer the following questions about the quadratic function. The quadratic function on that test is g of x equals, I have a negative x squared plus 4x again. That's interesting. And then it's minus 1. Okay, and it asks some questions about maximums and minimums. It asks, does it have a maximum or a minimum? If it does, where does it occur? And so forth. So this is a parabola. Do you know how this parabola opens? It opens down. How do you know, Keely? Yeah, the negative in front of the x tells me. So since it's opening downward, it's got this kind of an image, right? Is it going to have a max or a min? Max. So whether or not you can finish the problem or not, you should still be able to identify that this has a max just by looking. No work needed. It has a max. The question of where does it have a max is a question of where's the vertex happening. The where is the x value. The maximum value is the y value. So if we can find the vertex, we can answer the rest of the question. So we found a vertex a moment ago. We factored out a negative. It became negative 4x in the middle. And on this one, I have negative 1 at the end, not 12. That's fine. It's the same value inside here, because I divide the middle term by 2 squared, doesn't change. And then on the outside as well, if you'll remember, that 4 is actually a negative 4 that I've added, so I have to compensate with a positive 4. So much like the last one, this is now x plus 2 minus 2, quantity squared. But at the end, I have positive 3. So if you'll remember, that means my vertex, not exactly what I was asked to find, but my vertex is 2, 3. So the first question, is it max or min? It's a max. The second question is where? Where is it? Where means x value. What x value does that maximum occur at? 2. And the second, or the third part, part 3 says, what is it? What is it is asking what's the y value, and the y value is 3. So So it's a 3 as your maximum value. We want time for one more question if there's one more between 21 and 24. 20 what? Between 21 and 24. I promise we'll do 26 next time though.
Test one version of this.
Yeah, we'll stop with that one, sure. Test 1, number 24. It is got a 3 in it, which makes the problem look a little different, of course. So same question, max or min, and so forth. So the g of x on this one is negative 3x squared minus 30x minus 72. Bigger numbers. Okay, first, is it a max or min? It's a max. Opening downward because the negative in front of the x squared. So when I do this one and I factor out the negative 3, I'll have x squared plus 10x on this one. Okay, is that good for everybody? Put this negative 72 at the end, pull out the negative 3 at the beginning. All right, middle term's 10. 10 divided by 2 squared, 25. So there will be a 25 that goes in my blank. But I didn't really add 25. What did I really do? Subtracted how many? 75. 25 times 3. It's like a quarter, right? 3/4 is 75 cents. I subtracted 75. So how do I have to compensate from subtracting 75? Adding 75. Right? Okay, cool. And if I clean that up, I now have negative 3 at the beginning. I have x. In the middle is always the middle term divided by 2, so plus 5, right? 10 divided by 2 is 5. And at the end, I have plus 3. So just for practice, what's my vertex? Close. Negative 5, 3. And using that, I can answer my other two questions. The first one is, where is this maximum? Yeah, it's at x equal negative 5, or just you can just say negative 5 if you prefer. And what is it? It's y equals 3 or just 3. Okay, so here's what we'll do next time. We will finish the questions that you have from this test. All right, so anything that you still have, like Michaela mentioned, when I look at 26, anything that we still have from 21 down to, I think it goes all the way to 30, we'll answer those questions first, and then we'll look at redo questions because I should have the redos with us next time as well. Have a lovely evening.